Hi everybody, in this video I am going to discuss rotation in AVL tree. We know the AVL tree is a height balanced tree and it follows some properties. That is, one is left heavy, another is right heavy, and another is balanced. Left heavy, right heavy, and balanced. This is a height balanced managed tree. It is based on Adelson, Belsky and E.M. Landis. So let us consider the rotation in AVL tree. Rotations in AVL tree. There are four rotations in AVL tree. One is LL rotation. LL means left, left. Another is LR. Next one is RR and RL. LL, LR, RL, RR. So these are the four types of rotation that are used in AVL tree rotation. First of all, LR rotation. Consider the LR rotation. Let us consider the, suppose this is C, and this one is suppose is B, and this is now an AVL tree because the height of the left subtree is 1 and height of the right subtree is 0. 1 minus 0 means this is plus 1. Remember, balancing factor equal to height of left subtree minus height of right subtree. So this is the formula for balancing factor for any node. Height of right subtree. So balancing factor can be plus 1, minus 1 or 0. Left heavy means plus 1. Right heavy means minus 1 and balanced means 0. So this is the rules for finding balancing factor, height of the left subtree minus height of the right subtree. First of all, consider this balancing subtree. C, the B, when B inserted, B should be the left hand side of the C. Now the height of the C is left 1 and this is 0. 1 minus 0 means this is 1. And this height of the B is 0 because this is a leaf node. So this is the AVL tree. Now when you want to insert another node, suppose I want to insert A, C, A is smaller than C and smaller than B. So it is put into the leftmost position of the B. Now height of the C is 1, 2. This is plus 2. Height of the B is 1 and there is 0. Height of the left subtree is 1, height of the right subtree is 0. In case of C, height of the left subtree is 2 and this is 2 minus 0 means 2. This is 1 minus 0 means plus 1 and this one is 0. Now this is not a AVL tree. It's not an AVL tree. So how to convert it into AVL tree? In this case, rotation is used. Rotation is used to convert non-AVL tree into corresponding AVL tree. The rule is, this one is for LR rotation. Why it is LR rotation? Because last node inserted is the leftmost position of the left subtree. This is the left subtree and A is inserted in the leftmost position. So left. It is in such a leftmost node of the left subtree. That's why it's left. Leftmost node of the left subtree. That's why it is left. In case of left rotation, we need to perform clockwise rotation. This is a clockwise rotation, and B is the new root. C goes to the right hand side of the B, and A is the left side of the A and B. Now this is again a AVL tree because the height of the B is left heavy, left subtree is 1 and 1 minus 1 is 0, this is 0, 0 and it is now an AVL tree. So rotation are used for converting non-AVL tree, this is non-AVL tree into its corresponding AVL tree. LL, when we use LL, mean the last insert element is the leftmost side of the left subtree. This is the leftmost side of the left subtree. So we need to rotate this subtree and convert it to ABC. So this is the first. Now consider the LR rotation. LR means left-right rotation. LR rotation. Suppose this is the B. Now A. Suppose this is C. And A is the left hand side of the C because according to Bunny's tree, as it is less than C, so it moved to the left hand side of the C. Now this is an AVL tree because the height is A1, 0 means plus 1 and this is 0. So this is AVL tree. Now C, A and insert B to the right hand side of the A. Now it is not an AVL tree. Why it is not an AVL tree? Suppose this one is the node and height of this C is 1, 2 and this is 0. 2 minus 0 means plus 2. And this is 0 minus 1, 0. As the balancing factor is not either 0 plus 1 or minus 1. So it is not an AVL tree. Not an AVL tree. We need to convert it into AVL tree. First of all, why this LR? Because initial position of the subtree is left subtree. Then the last inserted element is the right hand side of the left subtree. So that's why LR, left then right. In case of LR rotation, we need to calculate the rotation values, that is in the right. First of all, lowest value, that is anti-clockwise, and this one is clockwise. First of all, B with the root, A go to the move to the left hand side of the B, and C move to the right hand side of the B. Now the balancing factor is 1 minus 1 is 0, 0, 0. So this is now an AVL tree. So this is the LR rotation of the AVL tree. In case of LR rotation, we need to check whether it is left hand side. Then last insert element is the right hand side. We need to consider 3 elements. Lowest element, then next one, and this next one. As it is plus 2, so we need to convert it into rotation of AVL tree. So this is the LR rotation. Now let us consider the RL rotation. Mean RL rotation. Suppose this is D, this one is F. This is plus, as the height of the D subtree left hand is 0, 0 minus 1 is minus 1, 0. So this is an AVL tree. Now suppose I want to insert F, E. E is greater than D, but it's less than F, so it moves to the left hand side of the F. Now the height of the D is 0, minus 2, minus 2. This is 1 minus 0 plus 1, and this is 0. This is not an AVL tree. Not an AVL tree. Now we need to perform the RA rotation. Why RA rotation? The initially subtree was right heavy, right subtree. Then last element inserted is, that is left hand side of the right subtree. So we need to perform RA rotation. In case of RA rotation, first of all consider the clockwise rotation, then anti-clockwise. In clockwise, E is the root, F is the right side of the, we move to the right side of the E. Now D move to the left hand side of the E. Now this is 0, 1 minus 1 is 0, 0, 0. This is an AVL tree. This one is RR rotation. Suppose A is the initial node, and when you insert, suppose B is greater than A, so it goes to the right hand side of the A, and height of this A node is 1, 0 minus 1 is minus 1, and this one is 0. Now when you insert next node, that is C, and it is the right hand side of the B again, then it forms right rotation. Right, and then goes to right position. This is right position. Now height of this A node is 0, 1, 2, means 0 minus 2 is 2, and consider this level, 0 minus 1 is minus 1, and leaf node is 0. Now it is AVL tree. It is not AVL tree, not an AVL tree, and this one we need to convert into an AVL tree again. Now this is RR, because the last node is starting the right position of the right subtree. Now it is RR rotation, RR clockwise. Anti-clockwise mean this is B is the root node, and A is the left hand side of the B, and C move to the right hand side as it is remain C. Now height of this is 1 minus 1 is 0, and leaf node as it is 0. Now it is an AVL tree. So this is an RR rotation, right. In case of right, we perform anti-clockwise rotation. In case of LL, we perform left mean clockwise rotation. When any node is more than 0, 1 or minus 1, so we need to perform 4 kind of rotation. This is LL, LR, RR and RL. So thank you very much for watching this video. Share and subscribe it.